Anti-differentiation, the opposite process to differentiation. I have to say that I'm not a particular fan of the term anti-differentiation and prefer to call it integration, which is what it is called later on when you actually learn more about the notation. So it's the opposite process of differentiation. However, we need to consider the following. If y is x squared, then we know dy dx is 2x. But also if y is equal to x squared plus 1, dy dx is 2x. And if y is x squared minus 1, dy dx is 2x. If y is equal to x squared plus 6, dy dx is 2x. In fact, if y is x squared plus any constant at all, then dy dx is 2x. This means that if the basic shape of the curve is y is x squared, it doesn't matter whether it is raised or lowered along the y-axis, the gradient of the tangent will always be equal to 2 times the x value at that point. Might be worth a quick diagram. So y equals x squared, we know, has a turning point at the origin. And let's suppose we had this point here, which was x squared plus 4. If we go along here to 1, then what we're saying is the tangent here is equal in gradient to the tangent here. So previously we saw that if y is ax to the n, then dy dx is anx to the n minus 1. Thus we multiplied the coefficient a with the index and reduced the index by 1. So basically the n drops down in front and multiplies the a, and we reduce the power by 1. In the reverse of this process, we will increase the index by 1 and divide by the new index. So if dy dx is ax to the n, then y is equal to ax to the n plus 1, so increasing the power by 1, divide by the new power, and then we add this constant on the end. We need to add the c because we are aware that there may be many functions that have the same differential, as we discussed over here. An antiderivative is conventionally shown using the capital letter of the function name. So let's suppose we have a function f of x. We know when we differentiate it, we write that as f dashed x. What we're saying is when we anti-differentiate, or I prefer the term integrate that function, then we'd call it capital F of x.